Welcome to the DIY Honda Garage channel. This presentation addresses DTC B1229, which is flagged by the DTC indicator E and Auto in the 2011 to 2017 Honda Odyssey. The error signifies an open in the sunlight sensor circuit, which is crucial for regulating climate control based on sunlight exposure. The sunlight sensor, located on the vehicle's dashboard, detects the intensity of sunlight entering the vehicle and sends signals to the climate control unit to adjust temperature settings accordingly. When the circuit is open, it disrupts this signaling process, leading to potential climate control issues. Effective diagnosis of this code will ensure that the vehicle's interior climate remains comfortable in changing light conditions. This guide will detail troubleshooting steps, helping technicians identify and resolve the underlying causes of the DTC. DTC B1229 indicates an issue with the sunlight sensor circuit, specifically relating to the sunlight sensor located in the dashboard area of the Honda Odyssey. The sunlight sensor functions by detecting the amount of sunlight entering the vehicle and communicates with the climate control unit to adjust the air conditioning accordingly. This adjustment is essential for maintaining a comfortable environment inside the vehicle. When this circuit is open, the sensor cannot send or receive the necessary signals, which ultimately compromises the effectiveness of the climate control system. Thus, understanding the sensor's role and its location is vital for diagnosing and remedying the issue related to DTC B1229. Proper evaluation of this component should be part of any troubleshooting approach to ensure the climate control system functions as designed. The potential causes of DTC B1229 primarily include wiring issues, loose connectors, or a faulty sunlight sensor itself. Wiring issues may manifest as broken or frayed wires that fail to make a complete circuit, disrupting communication between the sunlight sensor and the climate control unit. Loose connectors can also hinder electrical contact. If the connectors are not properly seated, or if corrosion is present, this could result in intermittent signals or total failure to communicate. Lastly, the sunlight sensor may itself be defective, which could lead to a complete circuit failure. Proper diagnosis of each of these potential causes is essential for a successful resolution of the DTC. Therefore, every mechanical component involved must be thoroughly examined. The symptoms commonly associated with DTC B1229 can significantly affect the performance and comfort of the vehicle's climate control system. One prevalent symptom is that the climate control system may fail to operate as intended, failing to provide the right temperature adjustments needed based on sunlight intensity. Consequently, passengers may experience inconsistent temperatures, making the cabin environment uncomfortable. Additionally, the DTC indicator light will remain active on the dashboard, alerting the driver to a fault in the system. If these symptoms manifest, it is essential to conduct diagnostics promptly to ensure that appropriate action is taken to identify and rectify the underlying issues affecting the sunlight sensor and associated components. The first troubleshooting step in diagnosing DTC B1229 involves clearing any existing diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. The HDS is a specialized diagnostic tool designed for Honda vehicles, which allows technicians to read and erase codes from the vehicle's onboard computer. Clearing the DTCs resets the system and aids in determining whether the fault is persistent or intermittent. This initial step sets the stage for subsequent diagnostics. If the DTC reappears immediately after the reset, it confirms that there is indeed a malfunction within the sunlight sensor circuit. Utilizing the HDS efficiently ensures that technicians can gather necessary data and take appropriate action based on the results. The second troubleshooting step involves turning the ignition switch to the lock 0 position and then back to the on 2 position. This process is crucial for ensuring that all systems are adequately reset and initialized before performing further diagnostic functions. By transitioning the ignition through these states, technicians allow the vehicle's onboard systems to refresh and recheck their operational statuses. This may assist in eliminating any residual faults that may cause incorrect readings. It also prepares the vehicle's electronic systems for subsequent diagnostic assessments, establishing a clean state where diagnostics can be performed accurately. This step is integral in guaranteeing that the troubleshooting process is effective. In the third step, technicians need to perform the self-diagnostic function either with the Honda Diagnostic System, HDS, or directly with the climate control unit. This self-diagnostic procedure enables the vehicle to check itself for any issues related to the climate control system, specifically delving into the functionality of components like the sunlight sensor. During this process, the onboard computer evaluates system parameters and identifies any failure points within the circuit. The HDS provides detailed error codes and descriptions, assisting technicians in understanding specific faults and guiding them in troubleshooting. This step is crucial for isolating the root cause of the DTC and determining the best path forward for repair. The fourth step requires checking for the presence of diagnostic trouble codes, DTCs, after completing the self-diagnostic function. At this point, it is vital to determine if DTC B1229 or the E and auto indicators are still being displayed. If the DTC remains present, this indicates an ongoing issue with the sunlight sensor circuit, and technicians should proceed to the next steps in the diagnostic process. Conversely, if no DTCs are indicated after the self-diagnostic, this could imply an intermittent failure. In such cases, it is crucial to inspect for loose wires or poor connections within the sunlight sensor circuit, as intermittent failures can often be attributed to these common issues. Understanding the diagnostic results will guide technicians toward the correct next steps. Following the diagnosis in Step 4, the technician should turn the ignition switch to the lock 0 position. This is an essential safety precaution, ensuring that all electrical systems are powered down before any deeper probing into the circuit is conducted. Once the ignition is locked, this prepares for the process that follows: disconnecting the sunlight sensor connector. Properly powering down the system protects the technician from potential electrical hazards and prevents damage to sensitive components during diagnostics. Ensuring that safety protocols are followed at this stage is crucial, as it prepares the technician for effective and safe component checking. In the sixth troubleshooting step, the technician is required to disconnect the sunlight sensor by removing the 5P connector. This connector is specifically designed to facilitate communication between the sunlight sensor and the climate control unit. Disconnecting it allows for a direct assessment of the sunlight sensor's condition and helps in diagnosing potential faults in the circuit. When disconnecting the connector, care must be taken to avoid damaging any pins or connections to ensure that they remain intact for future reconnection. Once the sunlight sensor is disconnected, it allows for individual testing and inspection, which is necessary to verify that the sunlight sensor itself is functioning properly and that the wiring leading to it is intact. The seventh step in the troubleshooting process requires disconnecting the climate control unit connector B, which contains 16 pins. The 16P connector is integral to the operational connection between the climate control unit and several sensors, including the sunlight sensor. By removing this connector, technicians gain access to the circuit and can perform continuity checks to ensure proper communication pathways. This step is necessary for isolating the components involved and further understanding any faults that may be present in the system. Special attention should be paid to avoid damaging the connector or its pins during removal, as proper reconnection is crucial for subsequent diagnostics. Step 8 entails checking for continuity between climate control unit connector B terminal number 3 and sunlight sensor 5P connector terminal number 2. Continuity testing is critical in determining whether there is a complete electrical path between these two connection points. If continuity is present, it suggests that the wiring and connections between these components are intact and operational. Conversely, if there is no continuity, this points towards an open circuit that requires attention. Identifying any breaks or disruptions in wiring can be a pivotal step in repairing the fault related to DTC B1229. It's essential to utilize a multimeter or similar testing device to verify the circuit integrity accurately. In the 9th troubleshooting step, technicians must disconnect the climate control unit connector A, which has 28 pins. This connector is responsible for facilitating additional circuit connections pertinent to the operation of the vehicle's climate control system. By removing this connector, it allows technicians to perform further tests to ensure the integrity and functionality of all related circuits. Disconnecting the connector is a necessary step in ensuring that troubleshooting is conducted with clarity, as it eliminates potential interference from other system components when checking for faults. This isolation aids in narrowing down issues specifically to the sunlight sensor and its immediate wiring connections. The 10th step involves checking continuity between climate control unit connector A, terminal number 13, and sunlight sensor 5P connector, terminal number 4. This continuity check is essential for confirming whether a complete circuit exists between the specified terminals. Presence of continuity indicates that there are no breaks or disconnections in the wiring between these 2 points, which is critical for the proper functioning of the sunlight sensor circuit. If continuity is absent, this signifies another possible open circuit that may need repair. Employing an accurate tool like a multimeter will assist in effectively assessing the state of the wiring. Ensuring that all connections are functional is vital to resolving the issues associated with DTC B1229. The final repair verification step requires that technicians confirm the complete resolution of the issues related to DTC B1229. After repairs or adjustments have been made, conducting thorough diagnostics is crucial to ensure that no DTCs are active. This step verifies that the sunlight sensor circuit is functional and that climate control is responding correctly to changing sunlight conditions. Once the technician clears the codes, they should monitor the vehicle to ensure that the DTC does not reappear after driving or after additional self-diagnostic checks. Successful verification is key to ensuring that the repair has been effective and that the vehicle is back to optimal performance in regulating climate control. Preventive maintenance is critical in avoiding future occurrences of DTC B1229. Regular inspections of the wiring connected to the sunlight sensor and the climate control unit are essential to catch any early signs of wear or damage. Loose or corroded connectors should be addressed immediately upon detection, as these issues can lead to intermittent faults or complete circuit failures. Maintaining the integrity of the electrical connections can greatly enhance the reliability of the climate control system. By proactively checking these components, vehicle owners can prevent the discomfort and inconvenience associated with climate control failures due to malfunctioning sunlight sensor circuits. Establishing a routine maintenance schedule assures long-lasting performance and reliability. In conclusion, addressing DTC B1229 effectively involves identifying root problems, following systematic troubleshooting steps, and implementing preventive measures to avoid future issues. The sunlight sensor plays a critical role in regulating climate conditions in the Honda Odyssey, making its proper functioning essential for passenger comfort. Through careful diagnostics, via steps like continuity testing and monitoring of DTCs, technicians can accurately isolate and repair faults within the sunlight sensor circuit. Furthermore, incorporating regular maintenance practices ensures the longevity and reliability of vehicle systems, ultimately enhancing owner satisfaction. By understanding this process, both technicians and vehicle owners can be more informed and proactive about maintaining optimal climate control performance. Please like and subscribe to the channel. See you next time!